arc that is the same length as the radius. Okay, so when this arc right here is exactly the same length as the radius, then this angle is defined as being 1 radian. Okay, so this right here, 1 radian. 1 radian. Now, we'll talk about the connection between radians and degrees in a little bit, but as you can tell, okay, as you can tell, there are going to be approximately how many radians in one complete, approximately, okay, it looks like maybe 6. Now, my diagram is not very good, it's not very exact, but you're guessing, okay, that's pretty close, okay, you're right, that's pretty close, about 6. Do you know how many exactly? Well, I don't want to go there quite yet. Okay, well, 1 radian. Okay, so 1 complete circle is, yes, 6.28 radians. To be exact, 1 complete circle in degrees is exactly 2 pi radians. Okay, so let's write that down. 1 full revolution is 2 pi radians. 1 full revolution is 2 pi radians, and that is, of course, the angle measure. Which means that 360 degrees equals 2 pi radians. Now, when we symbolize radians, okay, we don't usually use a unit. Okay? We don't usually use a unit. So if you want, you might see in some places an exponent with a capital R there. If you're really freaked out about there's no unit on this and you don't know what it is, you can put a little R there. But the whole idea is, part of the idea is that you don't have to have a unit for radians. Okay? So let's go back to this little diagram here. Actually, where did it go? Oh yeah, up here. This little diagram, okay, from the first part. And we didn't want to get rid of that. Okay, we have some degree measures here, right? Well, 0 radians is the same as 0 degrees, so 0 and 0 is good. What about 360 we said was 2 pi radians? What do you think 180 would be? Yes, just plain old pi radians. You don't have to write 1 pi, just pi radians. What about 90? Okay, half a pi or 0.5 pi. Technically, you should write it as pi over 2. Pi over 2 radians. You can write it as 1/2 pi. Try not to use decimals if you can. Get away with it. Don't use decimals. But anyways, what about this one here? If we're not using a decimal, we're using a fraction. And let's keep it in terms of pi. That's important. Okay. What's 270? Yes. 3 pi over 2, or 3 over 2 pi. Or, check this out. This is a half pi. This is 2 halves of a pi. And this is 3 halves of a pi. 3 halves of a pi. And this, of course, is 4 halves of a pi, or 4 over 2 pi, see? Which is the same as 2 pi. Well, yeah, this is 1 pi. They're saying that this is 1 full pi right here. Now, we're not talking about like a fruit pie, where this whole thing is 1 pi. No. In math, only this is 1 pi right here, just half of it. Half of the circle. Okay? Okay. Yes, that's right. In this special math world that we live in here, yeah. Yeah. A quarter of a pi is actually half a pi. You should feel really privileged. Okay. So here's my question. 1 radian is how many degrees? 1 radian is how many degrees? No, one radian. It's actually in your textbooks if you can find it. You see? Okay. Now, did you do that on your calculator or did you find it in the book? You found it in the book. Okay, that's fine. Yeah, about 57.3. So it's a little bit less than 60 degrees, which would be, if it was 60 degrees, it would be exactly 6 of them in one full revolution, right? Because 6 times 6 is 360. Well, okay, why isn't it not 60? Okay, so 1 radian is this many degrees because 6.28 radians is 360 degrees. So if you did 360 divided by 6.28, now this is a rounded decimal, but if you actually did that, okay, on 360 divided by 6.28, you would get 57.32. So, see that? So 1 radian is about 57.3 degrees. So that was pretty close to what we drew up here, a little less than, a couple degrees less than 60. Okay? All right. I'm going to show you one more thing, and that is how to convert radians to degrees and back and forth. Okay? So here is how you do the conversion. We know that 360 degrees is 2 pi radians, right? Well, can we simplify this little fraction right here? 180 degrees is pi radians. So that means that we really can set up a proportion that says this. The degrees over the radians. This is the ratio. 180 is 1 pi radians. So if you write this down right here, I'm going to show you how to use this little proportion, and we're going to be able to easily convert from degrees to radians. So let me get a new page here. Just copy that. Oh, oop. Okay, let's put that over here. All right. So let me ask you this question. 303 degrees is how many radians? That's the question we're converting. Here's the easy part, and you can use your decimal. You can have a decimal answer, no problem. We know that 180 over pi equals degrees. Now I'm given degrees, so I plug my degrees. Okay, 180 degrees, 303 degrees, both on top, equals kind of blank radians. This is unknown, so let's make it x or something like that. And now you just solve for this missing piece right here. Okay. So here's the shortcut. X can be multiplied up like that, and pi can be multiplied up like that. So you cross multiply. You remember that sort of little trick there. So that's 180 degrees. X equals 303 times pi. And then how do I get x by itself here? If this is multiplied, I divide. So divide both sides by 180. And then I get x equals, do this on your calculator real quick, 303. And you can just write 303 pi like that. You don't even have to say times. Divided by 180. And there you have it. 303 degrees is 5.28 or 5.29 radians. If you wanted to take this and you say, okay, if I need radians, right, if that's what I need, what I'm going to do is I'm going to do this. I'm going to do the degrees times pi over 180. Okay, you can do that. And if you need degrees, if you want to say, okay, I need degrees, so I'm going to do the radians times 180 over pi. You can do that as well, knowing that you multiply the other one by either pi over 180 or 180 over pi. And if you're given degrees, you multiply it by pi over 180, because the degrees and the degrees will cancel out. So I don't know if this would be easier for you or not. I like this because this is easy to remember and it's foolproof, as long as you know how to cross multiply and divide. But yes, this is the conversion factor right here. Either pi over 180 if you're given degrees, or 180 over pi if you're given radians. So if you could, yeah, as long as you get it straight. Okay. Any other questions? Okay, so if you just look at the in summary with me, girls. All right. Radian measure is an alternative way. Let's get that underneath there. To express the size of an angle. Using radians allows you to express the measure of the angle as a real number without units. Remember, we said we don't have to put the radians as units there. The central angle formed by one complete revolution is 360 degrees, or 2 pi radians. I should say 2 there. 2 pi. All right. Now, 1 radian is equivalent to close to 60. We said it was 57.3. Pi radians is 180. 2 pi is 360. Decimal approximations can be used as benchmarks to visualize the approximate size of an angle in radians. So what they're saying is that 360 degrees, right? So that, I don't know why, this is a clock, I guess they're starting here. All the way around, 360 degrees is about 6.3 radians. 90 degrees is about 1.6. 180 is about 3.2 or 3.14. And then 270 is about 4.7. So you can use those as sort of benchmarks, because if I asked you to, let's say, what is this angle right here, then you could say, well, it's between 4.7 and 6.3, so maybe that's around, 5.1, I don't know, 5.1. So you can do that to guess. Okay, questions?